Again, we have a symmetric system, and we're using these substitutions over here. We've been doing it for a while. I do want to claim, though, that some students are going to be looking at this, and they're going to look at this like, how did you get that? Well, I want to point out what I did do, and you want to try this on your own. I said that x cubed plus y cubed is really just x plus y, and then it's going to be x squared minus xy plus y squared, and then it's x plus y equals 112. And then I kind of associate these two together. That's x plus y squared. Then you get x squared minus xy plus y squared equals 1112. Whoops, 1112. And then you plug it in, and you do a manipulation, and you divide both sides by a number that's divisible to both sides, which is 4. All right, 4 is the actual number you get there, and you get it. You'll get, if you try, you'll get it. Now, if you look at this, and say, I'm not going to do any work. It's never going to go there. It's just never going to go there. You look at that and say, how did someone get that? They got that by working. So again, I want to emphasize over here, you need to take this, let me highlight it for you, and you need to do work to get this. It requires work. Paper, pencil, and you'll get to that. All right, then the next thing, what I did was the second equation, and let me point out what I mean by that. This one over here, I did more work. And what did I get? I get this thing over here. All right, so then I'm kind of looking at those two, and then I decided I'm going to eliminate something. And I realized it's a jump in reasoning, but I want to eliminate the v squared. All right, so what would I do? Let me write this over here. So u squared, and let me just write this down for you. So I want to eliminate the v squared. So what's v squared equal to? It's actually equal to 13 minus 3u squared. All right? So let's see if we can do that. And I'll plug it in. And it's going to be what? 39. Right? Because 3 times that is 39, right? Minus 9u squared. And that equals 28, right? Let's see if I did okay on that one. Let's see what I get there. Yep, I see minus 8u squared. And then I see, whoops, I'm sorry. It's minus 8u squared times u squared is u4. Sorry about that. And then I see 39u squared equals 28. And then I would see minus 8u4 plus 39u squared minus 28 equals 0. And then if you multiply both sides by minus 1, lo and behold, I would see this over here. I would see 8u4 minus 39u squared plus 20 equals 0. And I realize it's difficult, but I'm looking for a factorization of the problem, and I'm assured of it at this point that with a little bit of effort, including if you use the rational theorem, you get it, or make a substitution. All right, you'll still get it. All right, so I'm at like sort of the milestones in the problem. So let me get my eraser out. I'm pretty comfortable with what's being provided to me. All right, and then what I'm going to do now is, well, I got to do something, and what I'm going to do is just let what's the u? Well, the u could be 2. The u could be minus 2. The u could also be something related to this over here, which means 8u squared is equal to 7, or u squared is 7 over 8. I can multiply top bottom by 2, by the way, and that's 14/16. So what do you get over there? U would be plus or minus the root of 14 over 4. And that's why I'm putting this over here. Now, I realize some students are going to say, what are you going to do with that? Well, I got to plug it in somewhere. And I'm getting my eraser out. And not that I want to do all the detail, but someone says, where would you plug it in? I got to be honest with you. I think I would plug it in here because this is probably the easiest thing I can deal with. And if u is, let's just do the 2. If the u is 2, you would get 12 plus v squared is 13, and v squared would be 1, so v could be plus or minus 1. And I'll highlight that for you right over here. so forth and so on. If you do this, you'll get that. If you do this, you'll get this. And then what are these things over here? It's x and y. If you can't remember, this is what x is, this is what y is, and you kind of plug things in, all right? Now granted, it's nightmarish. I mean, you get this over here, you get this over here, this over here. It's work. And by the way, you may wonder how I got these. I had to work at it. There's no doubt about it. I mean, I had to put a lot of effort in to get that answer key. Could there be an error in the answer key? There could be, but I think it's unlikely. I mean, I'm not saying unlikely for everything, but the reason unlikely for this, because what I do, maybe I shouldn't say that. Errors really do pop up. But anyway, let's take a look. All right, let's see what we got over here. And I got to be honest with you, I got a large number of intersecting points. I want to look for easy ones first. And I wonder, do I see 3, 1? Yes. Do I see 1, 3? Whoops, I didn't mean to do that. Do I see 1, 3? Yes. I'm looking for easy, guys. Do I see -1, -3? Yes. Do I see -3, -1? Yes. And then I see 4 more points. By the way, when I graph these things, the machine does graph the point, but I must tell it the point. I actually have to type it in. I must tell the machine what that point is. What did I do? I typed in all 4 of these points. All 4. All right? Is that proof positive that they're the solutions? No. But you know what? They sure do look like solutions, don't they? Did I check in the original problem? No. But I think I'm pretty good with that. How many solutions did I find? 8. I mean, 4 really nice ones, 4 painfully difficult ones. But again, it's not easy. All right? I also want to point there's a trivial solution to the problem that you're not seeing. And it's this thing over here. Now, someone says, why is it trivial? Let's go back to the original system. And if you look at it, and many of you say, I don't even see it in the graph. It's not in the graph. So if you see this over here, I want to point out the clear solution to this problem here is it's plain as day when someone's pointed out to you, is when x is 0 and when y is 0. It satisfies both equations. Is that point plotted? No. Is that point easy to miss? It sure is. All right? So it's really, really easy to miss that. All right? So let me see if there's anything else I want to say about that. Clearly there's a trivial solution to this equation. Although we have a switch system, we could have used blah, blah, blah. Some other system would rather take a different approach. Okay, so I did take a different approach, and I want to point out where this is right over here. Zero product rule. Yeah, I guess I did something pretty crazy there, didn't I? Am I doing the same problem? Oh, I'm sorry. I apologize. I looked at a different question, and it happens sometimes. 0, 0 is not a solution to that equation. I apologize. I just really tired, and I looked at this, and I thought that was the equation we were dealing with. It's not. It's a true solution to the other equation now. All right, let me call it quits on that. We'll go to the next one in a moment.